Yeah. So yesterday, we have seen how to create the project in Eclipse, and also what are all the things we can write in the code, Java code. Suppose if we create class block or interface block and enum block, what are all we can write in those blocks we have seen. Okay. So we have static instance, methods, data types, variables, and inner classes, anonymous class, static blocks, inner interfaces, inner enums, okay, without name, with name, like that we have discussed. Okay, so before starting your programming, okay, so if you want to write Java program, so the basic things are you have to create any of these three blocks: class, interface, enum. Any of these three blocks help only you can write our Java program. So inside the block, what we can write, how to start our Java program. Okay, so there are few basics you have to know before starting your Java programming. So we should not blindly copy some code and we should not paste into our program. So each and everything we have to know. Okay, so to start your Java programming, so you need to know very few basics. So one is, first you have to know keywords. Okay, so keywords are nothing but names of predefined programs. Names of predefined programs. Okay, so when you use that keyword in background, that program will be executed. Okay, so keyword is nothing but some program name. Suppose yesterday we created, okay, one program. Okay, for class example we created one program as example class, or we created, it's okay, I will reopen again. I will close this window as of now. I will reopen the Eclipse. Okay, so yesterday we created few Java programs. So we created interface, we created uh, enum, we created class. Okay, like that we created, and we have provided some name to it, right? Okay, class name, interface name, and enum name. Okay, so whatever the name we provide, okay, that we call it as a keyword. Okay, so here keyword is nothing but names of predefined programs. Okay, already some programs are developed by Java. For those programs they have provided some names. Okay, those are called keywords. Okay, when you use any keyword in background, that program will be executed. Okay, so in our case, so we have used few keywords in our programming. Okay, so in class example, interface example, and enum example, we have used few keywords. So keywords, you can see in blue color we have some keywords: class, public, static, void. Okay, all these are keywords. Okay, so this is one program, and this is one program, and similarly static and void also some programs. So when you use these keywords in background, your compiler understand this program, and it will execute this program directly, your compiler. Okay, so it will execute and it will do some operation. Okay, when you use class keyword in background, it will create one dot class file. Okay, if you don't use class keyword or interface keyword or enum keyword, it will not execute any program and it will not create dot class. When you use public keyword, it will give the access to all others. Okay, it will set the access as public. Okay, so it will facilitate the access to everyone. When you use static, so static when you use, it will create the memory. Okay, by default it creates the memory. when you use static keyword to store the program into some particular memory location. When you use void, suppose if you perform some operation, okay, through this main method, when you perform some operation, suppose if you want to store the result into some memory location, okay, so you can use some other types, but here if you use void, it will not store your result. Okay, so whatever the operation it will perform, the end result it will not store. Okay, you can, if you want, you can print it in the console, but it will not store into the memory location. So void is nothing but empty. Okay, it will empty only, it will not store. What general meaning of void means empty. Okay, so we will discuss all these keywords. Okay, keyword is nothing but the name of some program, so when you use it, it will execute in the background. Okay, so first we have to know what are keywords. Okay, the second important part is you have to know data types. So data types also keywords. Okay, data types also keywords. But when you use data types, in the background, memory will be allocated. So memory will be allocated when you use the data types. And you have to know variables. Variables are nothing but memory names. Okay, suppose if you allocate some memory, okay, if you give some name, if you want to give some name to it, you can use the variables. Okay, names of memory location. Okay, so you have to know operators. Operators are, if you want to perform some operation. Okay, generally in programming languages, most of the time we do mathematical operations. So along with that, we have other operations. Okay, suppose if you take one word or sentence, okay, if you want to break that sentence, or if you want to convert that sentence into uh, capital letters format or small letters format. Okay, so if you want to perform any operation, we have operators. Okay, mathematical operator, like that we have so many operators. Okay, logical operator. If you want to compare two values, we have logical operators. Relational operator, if you want to relate some data. So like that we have different operators. Okay, so operators are very important in programming language. Okay, operators are nothing but, so it will do some operation. Okay, if you want to perform operation, so operator will perform the operation. Okay, it performs the operation between the data. Okay, these are the basic things you have to know if you want to start your Java programming. Okay, so first we discuss with the keywords. Okay, so keywords, then data types, then variables and operators. Okay, so we already using the keywords while writing our program. We already using the keywords. So let me open Eclipse. The same location I'm selecting. Yesterday I created this folder to store my Java programs. So inside that I created Java project. So it has to, okay, along with that we'll also open Yeah. So these are the most frequently used keywords. Okay. If you want to write your Java program, so all these keywords we use very frequently. Okay. Very frequently, very often we use all these keywords to write our Java program. Okay. So each keyword has one purpose. So keyword are nothing but it's a predefined program. Okay. So all these keywords we will use. Okay. This I will share with you. So as of now, we already use when creating interface class and enum code, we use it class interface enum. Okay. Public, void, static. We have used public, static, void. We have used. Okay. So again, these keywords are categorized into different ways. Okay. So if you so as I said, so data types also keywords. Okay, data types also keywords. Okay, so these data type category, in this data type category we have these keywords: boolean, byte, char, short, int, log, float, double, wide. Okay, so to provide the access to your code, okay, we have modifiers. Okay, access modifiers: public, protected, private, abstract, static, final, transient, violate. Okay, synchronized, native. We have. Okay, declarations. If you want to create some block, okay, these are the declarations. Okay, class enum interface. Okay, if you want to extend some class or implement some interface. Okay, what is extend implements? We will all these we will discuss later. Okay, so package also we have seen. Yesterday we have created the package. Okay, when I create the class, it is also taking the package name. Okay, folder name. Okay, package keyword. Okay, so when you use this package keyword, okay, it will understand that okay, this program is related to this particular package. Okay, similarly we have control flow keywords. Okay, so all these we will use. Okay, while explaining the program, again I will explain each and every keyword usage. Okay, as of now, to differentiate among these keywords, like what are the categories we have that I'm showing here. Okay, control flows are, suppose if you want to perform some operation based on some condition, or if you want to perform some operation repeatedly. Okay, so we have some keywords, those categories. So these are the keywords: if conditions, looping statements. Okay, so try catch blocks, like that we have some keywords. So we have other like keywords. Okay, those are also very useful, like this keyword, super keyword. Okay, instance of, if you want to check some object type, instance of null. Okay, this comes under some miscellaneous keywords. Okay, all these we use. So whatever I'm showing here, all these we will use. Okay, so volatile I may not use. Okay, transient also I will use. Volatile, native I may not use. And here, what else? All these things we will use. Instance. Okay, strict FP also I won't use. Okay, strict FP. Underscore anyway we can use. Okay. Yeah, only these three keywords. So we will not use. Okay. So volatile, native, and strict FP. Okay, there is no usage in our program. These keywords. Okay. So data types, as I said, data types are again keywords. Okay. When you use data type, some memory will be allocated in the background. Okay, so how to use the data types we have to know. Okay, and after creating the data type, okay, after using the data type, immediately we have to give the name to that particular memory location. Okay, once we create the memory, we have to give the name to that particular location. Okay, after that you can, if you want, you can store the value into that memory location. Okay, all these things we will see now. One more thing. Yeah. Okay, so like how to use keywords, I will explain while writing the program. Okay, so before starting writing the program, so we have to know, before starting our program, we have to know how to start my program, how to start my Java program. Okay, so let me create one class block. Okay, so if you want to write your program, so you need to create class block, give some name. Okay, so I'm giving the name as just example one. Example one. Okay, I require public static void main method also to run my program. Okay, without main method, you cannot run your program. So here you have four type of Java files, four Java files here. Okay, so when you if you want to run any of these Java files, okay, so this main method is required. Without this main method, you cannot run your program. Without this main method, you cannot run your program. So when I click on run button in Eclipse, okay, so which Java file will be executed? Which Java file will be executed? Okay, so if you have multiple Java files, when you directly click on this run button, so okay, whatever the tab is opened, okay, whatever the tab is open, that program will be executed. Okay, suppose if you open enum, I don't have the main block here. Now, when I run, which program will be executed? Which program will be executed? So let me run it. So whatever the tab you have, after that, if you have any other tab, that program will be executed. Okay, suppose if you are here in interface example, if you don't have this main block, if you try to run, again, it won't execute this enum block, it will execute the example one block. See, so here I did nothing. Okay, let me write some statement here. Sysout to write the systemout.println. Okay, instead of typing everything, you can use shortcut sysout and you can press control space. So it will automatically generate the code. Okay, example one. So when I run it, okay, I'm in this tab. Okay, it will directly run this file. So if I'm in some other file, but there is no method, there is no main method, it will not execute this particular block. It will go to the next step. Again, you will get example one. So suppose I'm in interface. I have commented this main method. Again, if I run it, it will go to the next file. It will check for the main block. And again, if it is not available, then it will go to example. Again, if you run, you will get the example. Suppose if I go to class example. So here I have main method. If I run here, it will execute this particular class block. Okay, when you have multiple blocks, so it will execute that. It will execute whatever the Java file, whatever the Java file having this main method, that particular Java file only it will execute. Okay, so if you want, you can call, you can access one Java file information into another Java file. Okay, so suppose if you write something into some class example that you want to access into example one, that you can access. Okay, suppose you have display method. Let me make it a static. Okay, so I want to print this a value from the example1.java file. Okay, so you can access that method into example1 Java file. How I can access? Just simply mention that Java file name. So basically, you should not consider Java file names. Okay, so in backend with the same name dot class file will be generated. Okay, dot class file. So technically, this dot class files we call it as class. Okay, so class interface or enum. Suppose if you are calling a class file related to which is related to class block, we call it as class. If it is related to interface, we'll call it as a interface. So here class example is my class block. Okay, so I will call it as a class. Okay, class example class. Okay, yeah, class example class. Class example display method. See, class example display method I'm calling. Okay, when I run it, when I run this file, example1 will be printed and also it will display the A value. So like that, we can access one class information into another class, one interface information into another class. Okay, like that we can access the different classes or different interfaces or different enums information into, so one to each other, vice versa. Okay, so one class information you can access one another class, one interface information you can access into class or interface. Like that you can share your logics. So when we create in the real-time project, okay, when we create Java programs, so entirely we create only one main method. Okay, so main method also we will not use basically. But if you want to create one project, okay, you have to create only one main method for all your Java files. Okay, you should not create multiple main methods. That is the basic rule. Okay, for project you should have only one main method. So sometimes we use main method also. So without main method also we can execute our program. For that we have unit test libraries. Okay, yeah. So yeah, so I have created example1 class. Okay, so remove these system.out.println statements. Okay, so I have a class block and also I have method. So what I have to write here? Okay, so this main method is to process my data. Okay, how can I pass the data to this method? How can I pass the data to this method to process my data? Okay, how to access my data first of all? How to store my data into memory location which is created by Java? Okay, so as of now, when you write this thing, it will not create any memory. It will not allocate any memory. Okay, to store your data. So we have to allocate the memory and we have to store. Okay, so to allocate the memory, we have data types. We have data types to allocate the memory. Okay, so we have data types. We have boolean, byte, char, short, int, long, float, double, and wide. So these are the data types we have to allocate the memory. So when you use wide, it will not allocate anything. Okay, all remaining 8, these will allocate memory. But all these are to allocate memory by again, why these many types? Okay, so when you use boolean, it allocates some amount of memory. When you use byte, it will also allocate some amount of memory. So there is a difference. Okay, boolean will create only 8 bytes of memory. Boolean, sorry, it's 1 bit of memory, only 1 bit of memory. Okay, when you use byte, it will allocate 8 bytes of memory, 8 bits of memory. Similarly, when you use char, okay, so char also it creates 1 byte. Okay, short 2 bytes, int 4 bytes, long 8 bytes, float 4 bytes, double 8 bytes. Okay, so again, why these types? Why these are required? Okay, so let's talk about our data types. Okay, first of all, data types are keywords. That is fine. These we use to allocate the memory. But when you look at this data types keyword, okay, data type. Okay, so as we discussed in the first class, one second. So data types we have discussed, right? See, so if you take any programming language, so to process the data only, so we use that language. So coming to the data, so data generally will be in the form of these types: numbers, characters, group of characters, symbols, and files. Okay, so based on the type, based on the type, based on the type of data, we have different keywords. Those we call it as data types. Based on the data type, we have keyword. Okay, so suppose if we take the general if you take the general data, okay, so this data generally we have categorized into general data. So numbers, characters, strings, and symbols. Okay. So again in Java, to save the memory, suppose so numbers we can have big numbers and small numbers, very huge numbers and very small numbers. Okay, if you allocate the common memory for all the type of numbers, what happens in the backend? Some memory will be wasted. Suppose you created some memory for the huge number. If you store very small number, some memory will be wasted. So generally for programming languages, whenever you use very less memory, then only your programming execution speed will be increases. Okay. Whenever you whenever you are executing, if you have very less memory, if you use very less memory for your programming, then it will be executed very fast. Suppose if you are using huge memory for to store your data, okay, huge memory created by your programming language, okay, again to process the data it takes a lot of time if you create more memory. Okay, so in Java, so we have so many techniques, okay, to minimize the usage of memory allocation. Okay, Java is very famous for that only. Okay, we have so many techniques. We have so many techniques for the reusability. Instead of again, every time creating the new memory for the data or for other things, we have so many reusable techniques, and also we have techniques to minimize the memory allocation. Okay, so that is the reason we have so many data types when comparing with the other programming languages like Python, C Sharp. Okay, so first we have, so if you take the numbers category, so numbers we have basically two types. Okay, normal numbers and the decimal numbers. These are simple mathematics. Okay, again normal numbers. Okay, they converted into small numbers and big numbers. Okay, so coming to decimal numbers. Okay, so here in decimal numbers you have floating numbers and double numbers. Okay, coming to the decimal numbers, float numbers and double numbers we have. These are the mathematic terms. Okay. Okay, in small numbers, we have short numbers, short numbers, and coming to the big numbers, we have integer type of numbers and long type of numbers. Okay, integer type of numbers and long type of numbers. Okay, so these are the numbers category in the mathematics. Okay, if you take characters, okay, all the alphabets are characters, all alphabets. Okay, each alphabet is a character. All alphabets and all symbols. Okay, in computer language, for all alphabets and all symbols, we call it as character. Suppose if you take one symbol, that is also a character. If you take some alphabet, that is also a character. All alphabets and all symbols are comes under characters. Okay, so in backend for these characters, generally we have ASCII codes. ASCII codes. Okay, so when you take some alphabet, by looking at it, appears as a alphabet, but in the back end, it holds some value. It holds some value. Yeah. So for the strings, we have, so whenever we say string, okay, it is a group of characters, some group of characters, or group of words. It can be anything. group of characters or group of words or group of or sentence. Okay, symbols we already covered in the characters. Okay, all symbols comes under character. So along with this data, we have true or false related data. Okay, suppose if you want to like compare the data, if you want to check the data for the end results, okay, in mathematics also, okay, we have true or false statements whenever we are comparing the data, either true or false. Okay, to hold that data, okay, for true or false, we have separate data type. Okay, so in Java, basically all the data, the common data, whatever we use regularly in the real world, okay, so that data they categorized into these many types. Why these many types? Okay, so for each type they have separate keyword. For small numbers they have separate keyword. For big numbers they have separate keywords. Similarly, for decimal numbers, characters, strings, and true or false statements to minimize the memory. Okay, so for short numbers we have keyword short only. For integer numbers we have keyword int. For long numbers we have keyword again long only. Okay, for floating numbers we have keyword float. For double number we have keyword double. For characters, for to store a single character or single symbol, so we have keyword char. And for group of characters, as if you want to store some sentence or group of character or group of words, we have keyword string. For true or false conditions to store the result, we have keyword boolean. Okay, so we have keywords boolean, but we have one more keyword. Okay, so in the small numbers category, we have one more keyword, one more number, byte type of numbers. Okay, so this is also a mathematical term. Okay, byte also a mathematical term. Okay, do not confuse. Okay, it is also comes under small numbers. Okay, for byte also we have keyword byte. Okay, boolean we have, byte we have, short, char. So let me put this char here. Int, float, long, double, string we have. The total, how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So nine type of data, 9 types of data, 9 keywords we have to allocate the memory. Okay. So coming to the last one, the group of characters or sentence to store group of characters or sentence, we have a special type that we can call it as a keyword, but technically we have another name for it. Okay, that we will discuss later. The basic data types, these are we use to allocate the memory for our to store our data. Okay, so along with that we have also wide type. Okay, so wide it will not create any memory. Okay, if you use wide it will not create memory. So this generally we don't use it for our variables. Okay, we use it for special purpose for the methods and all we will use. Generally we don't use it for variables. Okay, so whenever you want to process some data, if you want to process numbers related data, these many data types, most of the time we process the numbers related data only. Of course, we process the string type of related data, but most of the time we perform calculations. Okay, for calculations, so we use the numbers. That can be any type of number. Most of the time we use these data types. To check the result, to store the result, we use the Boolean data type. Okay, after performing the operation. Okay, so suppose if you are comparing, okay, so the end result, whether it is a false or true, if you want to check, for that we will use the Boolean type of data. Sorry, Boolean type of data type. Similarly, string. String is to store the some group of characters. What is string we will discuss later. Okay, if you observe this screenshot, all the keywords are in small letters. Okay, all the keywords are in small letter. Why these are in small letter? Okay, while writing our program, we will write some variables, some data types, some class block names, interface block names, method names. All these we will write, right? Okay, to differentiate among these types. Suppose like while writing your program, if somebody wants to go through your program, by looking at your program only, he has to understand what is keyword, what is method, what is variable, and what is data type. He has to identify. Otherwise, he cannot understand the program. Okay. Otherwise, no one will understand your code if you don't follow the rules. Okay. So to write our Java program, so we have some specific rules. Those we have to follow. Okay. So all the keywords, whatever the keywords we have, those all are in small letters. Okay, in the smaller case. So those keywords you have to use as it is. Suppose I have a public keyword that I cannot use like capital P. Your compiler cannot understand what is this public. Okay, if you start with capital P, when you use small p only, it can understand, because for this some logic they have given the name as in smaller case. Okay, when you use capital P, there is no logic behind. They didn't create anything. It is unable to identify that logic. Okay, so the names we have to use as it is. Okay, so all the keywords, whatever the predefined programs we have, those they have created with names with smaller case. Okay, yeah, and also while we create, we also create some logics. Similarly, how they created, we are also will create some logics. Okay, so we are also have to follow the same rules while creating our logic. Okay, there are some rules, those I will explain. Okay, so the first thing is all the keywords you should write as small letters. Okay, you have to use the keywords with smaller case words. You cannot use with any other case. Yeah. So coming to data types. Okay, as I said, all the for the to store the number type of data. Okay, to allocate the memory for number type of data. So we have these data types. Okay, so we have for each one we have memory size. Okay, so it is only 1 bit. When you use Boolean keyword in the backend, it allocate only 1 bit of memory. So in that you can store true or false. Okay, generally when you store true or false in backend, it stores 0 or 1. Okay, coming to byte data type, it allocates 8 bits of memory. Okay, so we call it as 1 byte. 8 bits in computer terminology, 8 bits are 1 byte. Okay, so when you use character, again it allocates 2 bytes of memory. Sorry, let me open the screenshots. Data type sizes. When you use character, okay, it allocates 2 bytes of memory. Okay, these are the sizes. Okay, Boolean 1 bit, byte 8 bits. Okay, 8 bits nothing but 1 byte. Char 2 bytes. 2 bytes are nothing but 16 bits. Okay, it allocates 16 bits. Okay, so character, so I already explained. So this character to store the characters. or symbols. Okay, short can allocate again 16 bits of memory, 2 bytes. So we have to know these all these types. Okay, even though these are basics, so we have to know. Okay, then only you can save your memory while writing your program. Unnecessarily, you will not waste your memory. Okay, whenever you use less memory, your program speed also will increase. Okay, so we have to mind this memory allocation also. Okay, so integer 32 bits, so which means 4 bytes. So float again 32 bits, but it is to store floating numbers. So long, it is 64 bytes, 64 bits, 64 bits. So it is 8 bytes. So similarly, double also, it can allocate 64 bits of memory to store the double numbers. String, there is no limit. No limit. If you use string, there is no limit to allocate the memory. So whatever the data you store while assigning, okay, by default it will allocate some some buffer memory location. It directly won't create any memory. Okay, we have memory types, different memory types. Okay, like string pool, constant pool, like that we have different memory types. Okay, again in the string pool we have buffer memory. Okay, by default it will not allocate any memory. Whenever you assign some value based on its content, the value length and the value content, it allocates the memory. Okay, there is no limit for the string. Okay, so these are the data types. So see, when I have 1 bit, okay, what I can store into that 1 bit of memory. Okay, so if you use boolean, you can store only boolean value, either true or false. In backend it takes 0 or 1. When you use character, you can assign only character. You can store only character type of data. You cannot store number type of data into the character. Even though it is creating the 16 bits of memory, you cannot store number type of data into the character. You have to store the character type of data. So generally characters we have to store in the form of, you have to store in the form of single quotes. Suppose if you want to store capital A, or if you want to store small a, or any character, if you want to store some symbol, okay, some at the rate symbol, if you want to store some asterisk symbol, or if I want to store number also, so number also is considered as a symbol. If you, even though it looks like a symbol in backend, if you mention it is in single quotes, okay, it takes as a character. Okay, so numbers you can directly define. Okay, byte, you can 8 bits of memory. Okay, so up to 127, up to 127 you can store. Okay, from minus 128 to plus 127 you can store. Okay, similarly, so for short also we have some range. For integer also we have some range. Okay, if you want to check the ranges, okay, if I use some byte data type, what is the value I can store? If I use short, what is the value I can store? So if you want to check the ranges, see these are the ranges. So when you use byte data type, it will allocate memory. Okay, in that memory you can store up to this value. Okay, between minus 128 to plus 127, any value you can store. More than that, it cannot handle. Okay, it cannot store more than 127 value. So let me show you the example. In this example, suppose I'm creating memory. Okay, so memory is byte. Okay, I'm giving the name as some a. How much value I can store? Up to 127, 5. Suppose if I want to store 128, it will give you the error. Your compiler only will give you the error. Your compiler knows, okay, it is allocated 1 byte of memory. Okay, it can store up to 127 only, it can store. Your compiler immediately throws the error. You cannot store this value. So that is the reason it is showing the error. Cannot convert from int to byte. See, whatever the value you provide, it is considering as a integer value. Okay, so it is giving the error like you cannot store this value, integer value, into byte. If you want to store, create a int type or convert this value into byte type. Okay, so this is the integer value. This value you convert into byte type, then I can store. Okay, how to convert all these things we will discuss later. Up to 127 only you can store. Suppose if you are creating a short. Okay, so let me write the variable's name as. Okay, again, while giving the name for the memory, you should not use the keyword names. Whatever the keywords we have, those names, those keywords, you should not use it as a variable name. Okay, these otherwise you cannot find the difference. If you are able to write the variable name as keyword name, you cannot find the difference between keyword and the variable name. So that is the reason we have restriction. You should not use keyword name as variable name, or keyword name as method name, keyword name as class name, block name. Okay, so you can use byte 1. Okay, when you put 1, it can differentiate. Okay, short 1. So for short also we have some range. Okay, for short, so up to 255 you can store. Okay, 255, it is fine. If you use 256, okay, what is the range for short? Okay, up to 32,767. Sorry, up to 32,767. 767. If you put 768, it gives you the error. Okay, similarly, we have int. For int, we have some range. Okay, some number 2147 483647. Okay, no need to remember all these values. Okay, so at least you have to know. Okay, so for big number, what is the type I have to use? For small number, what is the type I have to use? You have to know. Okay, if I put 8, it is giving the error. So long number you can store into. Suppose if you put 48, you can store into the long. Okay, so the thing is whenever you do, sorry, it is long. Okay, but the thing is whenever you use bigger data types, okay, generally it is not preferred to use bigger data types in any programming language because it unnecessarily wastes our data. Okay, whenever you declare bigger data types, to that value you have to give that type also. You have to mention that data type also. It is a long number, so you can mention it as L, or you can mention it as capital L, small L, capital L. Okay, so your compiler knows that okay, it will occupy more memory. It will store into some other memory location. Okay, for bigger data types. Okay, so for floating numbers again similar. Float, we have some ranges. So generally float numbers, we call it as decimal numbers. If you want to store the decimal numbers, you can use the float. Okay, so float, suppose if you want to store 100.5, you can store. Okay, again, to differentiate double and float. Okay, so we have one more type of numbers, double type of numbers. To differentiate, it is a double number or float number. So we have to use small f or capital F, small d or capital D. Okay. So character. So if you want to store some character value, we have char data type. Okay, you can store. Suppose if you want to store small a or capital A, you can store. Similarly, if you want to store some symbol, so you have to use single quotes. Okay, or you can store the number also, but even though you store the number, okay, it will not consider it as a number. Sorry, suppose if I give 1, it will not give, it will not consider it as a 1. For example, let me take some integer, some int 2 equals to 1. Okay, so let me make it as static. This is also static. Why I'm using static, I will explain later. So now you cannot understand. Okay, let me print char and int. Those are one only, right? So let me print these two values. Okay, so first I will print char 3 value. Then I will print into 2 value. Into 2. Okay, into 2 value I'm printing, and char 3 value I'm printing. So both looks like same only, 1 1 only. But when you print it, okay, so let me put some space. Okay, so as of now it is printing as 1 only. Okay, suppose if you perform some operation, okay, by looking at these two values, these are looking at 1 1 only. Okay, suppose if I want to do some operation 1 plus 1, okay, so char 3 plus into 2. Okay, what happens? Let's see. If you run it, so you are getting value 50. Actually, it has to display 1 plus 1 2. Result 2 it has to display, but it is displaying as 50. Why it is displaying 50? So in the backend, even though you assign as a 1, in the backend it takes the ASCII value. Okay, ASCII value of 1 is 49. ASCII value of 1 is 49. ASCII value of 0 is ASCII value of 0 is 48. Suppose if you want to get the actual result, what you can do is minus, in single quotes you can put 0. If you run it, you will get the actual answer. Because ASCII value of 1 is 49, ASCII value of 0 value is 48. 49 minus 48 is 1, plus 1, it will become 2. Okay, let me show you that screenshot. ASCII values. Okay, so let me show you in the Google. ASCII codes. So let me increase. Okay, is it visible to everyone? This table.
Yes, Shiva.
Okay, it is visible, right? See, So here for numbers you have ASCII codes. Okay, so here suppose for characters. Okay, suppose you have numbers. So what is the decimal number you have? Okay, that comes under ASCII code. So here the first. Okay, so here see characters. For characters you have, for 0 you have 48, for 1 you have 49. Okay, so for see this is the character, this is the decimal value. Okay, you should not consider this hexadecimal and octadecimal. Okay, hexadecimal and octadecimal you can ignore. This decimal number only you have to consider. For null it is 0. For character null keyword, for null keyword the decimal number is 0. Okay, similarly you have other characters, whatever the like whatever you see on your keyboard, that we call it as character. Each keyword, each like letter on your keyboard, that we call it as a, each key on your keyboard, that we call it as a character. Okay, for 0 it is 48, for 1 it is 49. Okay, so when you are assigning the value, okay, the numbers also you can assign to the character data type, but you cannot use like a number. Okay, here again single character only you have to assign. More than one character, suppose if you put 0, it becomes 2 characters that you cannot assign into the character data type. Okay, only one key only you have to pass by look at your keyboard. Okay, so each key represent one key. Okay, one character. Okay, you can use either one character, more than one character you cannot use at a time in your keyboard. Okay, so to store different data we have these data types. Okay, similarly we have boolean. You can store either true or false. You can store either true or false. Okay, so we have one more data type. Okay, that is string data type. Here you have to use double quotes. Okay, if you want to store some group of characters, okay, you cannot store group of characters into a character data type. If you want to store group of characters, you can use string data type. Okay, so if you look at for all these types we have different color, right? These are these are in different color. Okay, coming to string, it is in different color, which means technically we will not call it as string as keyword. Okay, so you can call it as keyword, but it not comes under this category, this data type category. Okay, so basically we have two types of data types. Two types of data types. Data types are two types. Okay, so whatever we define here up to here, primitive data types. Primitive data types. What is primitive? What is the meaning of primitive? What is the meaning of primitive? Primitive is nothing but predefined. Okay, and referenced. Okay, what primitive is nothing but fixed, predefined or fixed data types. Fixed data type means for these data types we have a fixed memory allocation by your compiler or your JVM. Whenever you use this type of data types, okay, so these have fixed memory. Fixed memory is nothing but those can allocate the fixed memory. If you use Boolean, it can allocate only 1 bit of memory, not more than that. Okay. If you use double, it can allocate only 8 bytes of memory, 64 bits of memory, not more than that. That is the reason these are fixed memory data types. The memory already fixed by your Java compiler. It can allocate maximum up to that memory only. Okay, coming to the reference data type, there is no fixed memory. Okay, so we can call it as non-primitive data type. Non-primitive data type. Non-primitive means not fixed. Okay, this is fixed size. This is not fixed size. Not fixed size. Which means it can extend also. There is no fixed memory. Okay, based on the data, it will increase its memory location. Okay, so that is the reason in the back end we have two different types of memories. Okay, one is constant pools, another one is string pool. Okay, so all your primitive data types store into the constant pools because it has some fixed memory. Whatever we have non-fixed memory, those will be stored into the string pools. Okay, so in the string pool again we have buffer memories. That is the memory management that is not required for our course. But what is fixed memory size data types? What is not fixed memory data types? We have to know. Okay, so string is non-fixed memory. So that is the reason to differentiate primitive data type and non-primitive data type. So we have this color difference here. And also if you look at the naming, all these are in small letters. But coming to this string, it is starting with the capital S. Okay, so non-fixed memory type of data types, we start with the capital letter. There is a naming convention. What is that naming convention? I will explain. Okay, so in string, you can store anything. Okay, you can store a number of lines of data. It can be any data. It should be enclosed with double quotes to differentiate character and string. For character, you have to use. So character is nothing but a small one character. Okay, that you can store into single quotes. So here also in string also we use characters, but group of characters to differentiate. It is a group of character. It is a single character. For single char, we use the single quotes. For group of characters, we use the double quotes. Okay. So we have one more type of non-fixed memory. Okay. We have one more type of non-fixed memory. Inside that, you can store any type of value. Okay. This is also not non-fixed, non-primitive data type. Okay. In this, you can store any type of value. If you want to store string, yes, I can store string. If you want to store number, yes, I can store number. I can store number. Suppose if I want to store some number. Okay, object 2. If I want to store some character, yes, I can store character. Suppose some A, object 3. Okay, so we should not create duplicate names. Again, we have to remember, we should not give the duplicate name to the memory location. Okay, in a single Java, in a single class file or in a single block. Okay, similarly, if you want to store Boolean value true or false, yes, it is possible with this data type. It is also not fixed memory object, not fixed memory. You can store any type of value. Object can store any type of value. Okay, so from Java 11, we have one more type one more data type from Java 11 only. Okay, in earlier version we don't have this option. We have one more type, where. Okay, so using where you can store any value. Okay, so why it is not recognizing? So Java 11 only we are using, right? 1 second. Yeah, so for local variables only we have one this option. Okay, here it is taking. So using where you can store. What is local variable? I will explain. Okay, all these are variables. The names we are providing to the memory location, all these are variables. But if you write inside some logic block, method block, that we call it as local variable, you can store any type of value. Where 3, some character, some string if you want to store. For in where 4, you can store string. Suppose if you want to store true or false, using where you can store true or false as well. Where 5. Okay, so we have string, it can hold group of characters, sentences, or group of words. Coming to the object, it can hold any type of value. Again, where it can hold any type of value. Then what is the difference between object and where? Okay, so object, you can use it for both global variables and local variables. Okay, again variables are, we have categories that I will explain later. Global variables and local variables, those we will discuss later. Okay, suppose if you want to perform some operation on data, first you have to store that data into some memory location, then only your Java can process your data. To store your data, you have to allocate the memory. To allocate the memory, we have to use the keywords, predefined keywords. Those we call it as data types. Those we like we have two types of data types. One is primitive data type. So these 8 types are primitive data types. So primitive data types means fixed memory data types. Whenever you use that data type, it allocates that fixed memory. There you can store your data. And also we have non-primitive data types, reference data types. Okay, using which also we can allocate the memory, but memory will be allocated whenever you store the data into that memory location. Some dummy memory. Okay, size also it will not create. Just it gives the, like it allocates some memory, but there is no size for it. Okay, in buffer only. Okay, so whenever you store that data, that will be stored into the fixed memory location based on the data. Okay, so similarly we have where also it will create memory, same like reference data type. Okay, whatever the data you assign, that memory, that type of memory it will allocate. Yeah, so any doubts in data type? Okay, these are to store the data. How to process, I will explain.
Shiva,
Yeah,
then why we need to use int long that data type Shiva instead of using object?
yeah,
We can use object also now.
yeah, that's right. So whenever you use fixed size of memory data types, okay, your compiler already knows. Okay, this data, your compiler is already know what is the size of data. Okay, what is the size of data? Your compiler is already know. For the processing, for JVM processing, it is very easy to estimate its memory and process. But when we use these reference data type, okay, your compiler doesn't know whether you assign some fixed this length of string or some number of lines. So it cannot estimate the memory. Okay, in runtime. Okay, In runtime, suppose if you are assigning the value, okay, that time you will get a problem. Suppose if you are assigning huge value, okay. So primitive data types, it already knows the size of this data and these keywords information, okay. So it can easily process the data when you use the primitive data types. But coming to the reference data type, it cannot estimate its memory, and also we have different memory blocks, okay, in the backend. Okay, we have uh, heap memory, we have static memory, we have method area kind of memory blocks. Okay, so whatever we create with the reference data types, those goes to the heap memory first. Okay, so generally heap memory like eats our RAM memory. Okay, it occupies more RAM memory. Okay, these are not preferable, but most of the time in programming language we use this only. But for compilation, but for execution, okay, so primitive data types, if you use the primitive data types, these works faster. And also these reference data types, again, you cannot use the value as it is. Okay, suppose if I want to do some operation, okay, do some operation with int. Suppose I have assigned 10 to object 2 that I want to multiply with some byte. Okay, so let me do that. So let me make it as static. This byte also will make it as static. Why I am making as static, I will explain later. Okay, this is object 2. I'm performing multiplication operation with byte. Let's take byte. See, I'm getting error. This is also a number, and this is also a number, but still I'm getting error. Okay, so here there are some other things we need to discuss. Those you will understand later. So generally, I should not disclose these types, these two types. No, but to store the data, these are also available like that I have explained. Okay, these we have to discuss after few topics. Then only you can understand what are
Okay,
these.
sure, no problem. Okay.
Okay, yeah. Okay, differences I will explain later, but most of the time to store your numerical type of data, number type of data, so you have to use primitive data types. Okay, and characters and boolean also you have to use the primitive data type. String data type, okay, whenever you're storing group of characters or group of 4, then only you have to go with the string data type. Okay, so first we have to store the data into some memory location, then only you can process. Then how can I process my data? Okay, so data types, plus variables to store the data, right? Store the data to some memory location. Okay, that data you can access with the variable name. Okay, how I can process the data? So in Java, if you want to process, so we have to use the methods. Okay, so suppose if you create a block, either class block or interface block or enum block, so first you will store the data into some memory location with the help of data types and variables. To process the data, you have to create the methods. Okay, methods to process the data. To store the data, we have variables and data types. To process the data, we have methods. So we are already using the method. Okay, that is the default method provided by our Java. That is main method. The method name is main. Okay, these are the keywords. It will help to process this main method. by JVM. This is the main method we are already using. Suppose if you want to create your own logic. Okay, so processing means, what is processing? You will create some logic. With that logic, you will process your data. Similarly, if you want to create your own logic, you can also create your own methods. Okay, suppose there is a syntax to follow to create the methods. How we are creating the variable and data type. Similarly, for method also, we have to use the data type. Okay, so after processing, you may store your data, you may store your result into some memory location, right? Sometimes you may not store, just you will process the data and you will leave it. But sometimes you will store the data into some memory location after processing. If you want to store, if you don't want to store, we have data types. Again, if you want to store, you can use all these data types, whatever we discussed. All these data types you can store, all these data types you can use to store your result after processing. After processing the data, if you want to store the result, okay, again you can use all these data types. Okay, along with these primitive data types, you can use reference data types also. And also one more thing is, you can create your own data type. Okay, not only string object, where you can create your own data type and you can store that data type related data into that variable, okay, in that memory location. Okay, how to do that I will explain. Okay, so if you want to process your data, if you want to store the data into some result, okay, so you can use data types along with the methods. Okay, data type plus method name, logic name. Okay, so here if you want to write some method, you have to use the data type and its name. Okay, the syntax is data type, method name. Okay, so to differentiate the variable and method, we have to use parenthesis symbol. Okay, otherwise it will not understand. Suppose you are writing a variable like this. Okay, you are writing the variable like this, right? Suppose if you write a method also like this, how you can differentiate the variable, normal variable and the method? Okay, to differentiate, we have to use the parenthesis. Okay, syntax is like this. You can use any data type, either primitive or non-primitive. Either primitive or non-primitive type you can use. Okay, so if you want to write a method, first use the data type. Okay, so first I will write the method name. Suppose some display method, display. Okay, so method, again you are creating a logic, so you have to use it as a block. Otherwise it will mix with all these variables and everything. So you have to enclose it with curly braces. Whenever you use curly brace, which means it is starting from here and ending till here. Whenever you create class, it is starting from here and it is ending here. This method is starting from here and it is ending. Okay, so you have to use the data type. So we have all these data types. You can use all these data types, but if you don't want to store the result, we have one more keyword, that is void keyword. Suppose I don't want to store the result, I can use the void keyword. If I want to store the result, suppose addition method I have. Addition method I have. I want to store the result. Suppose I am performing some 10 plus 20. This result I want to store into some memory location. That time you have to allocate the memory, right? So that time you have to use that time you need to use data type. Suppose I'm creating some 4 bytes of memory with it. So you have to use the data type, and also you have to use return keyword. Okay, it will store this value into this created memory location with this edition name. How we are providing the name to our other variables. Similarly, with this edition name, this result value will be stored. When you call this edition name, this value you can access. Okay, display. So it will not store anything. Suppose if you want to display, I want to display object value. You can display it. It will not store anything. If you call display, it will display this value, but you cannot perform any operation with this value in other method. It only display the value. It will not store this value again. Again, if you want to perform the operation, you have to use this name. But this display method, it will not store any value. It will display the value. But if you use the data type, okay, after processing the data, the result will be stored. You have to use combination data type and return keyword you have to use. Okay, so if you want to process the data, you have to use the methods. You have to use the methods if you want to process the data. If you want to store the data into some memory location, so you have to use the data types and variables. Again, if you after processing, if you want to store the data, you have to use the data type and also return keyword to store the result value. And for that particular memory location, the method name will be taken. Method name will be taken to that particular memory location. Okay, so these methods and the variables and the data types we use to write our Java program. Okay, so these are the very basic things. So you have to handy with these data types. Okay, whenever I say byte, the purpose you have to know what is the use of byte, what is the use of short, what is the use of string, what is the use of object. Similarly, what is the use of var keyword, what methods do. If I want to store the value, result value, what I have to do. All these things you have to know. Okay, what is the use of while. So static and public I will explain later. Okay, so what is static and what is public I will explain later. So here also I'm using static. Okay, so without using static also I have created variables. What is the use I will explain later. Okay, so these data types, variables and methods are very important to write your Java program. Without variables, without methods, you cannot write your Java program, because Java is to process the data. If you want to process the data, you require data types, variables and methods. Okay, so technically these we call it as the variables and methods, we call it as properties of a class. Class properties, class features. Okay, how humans have the features. Okay, similarly this particular block also having these features, these variables and methods. Okay, yeah, so this is enough for today. Okay, tomorrow we will discuss operators. Okay, along with the operators, I will not take it as a just I will explain the basic operators, and while using it I will explain. Okay, tomorrow we will discuss operators, then we will start the object oriented programming. Okay, what is object oriented programming? So before starting it, I have to explain what is static and what is instance, how memory will be allocated. Those I will explain. After that, we will start the object oriented basic Java features. Okay, we have 4 categories, right? If you take any object oriented programming, if you are not aware of those topics, no need to worry. Okay, so we have basically 4 topics in object oriented programming. What are those? We will discuss tomorrow once we're done with the operators. Okay, yeah, so let me stop the recording.